Hey guys, how's it going? So I am super excited about today's video because we are going to be writing our first Solidity smart contract. Now, this first one is going to be fairly simple, just under 30 lines of code or so, but it should give you a good basic understanding of the structure of a Solidity smart contract, introduce some basic principles, and show you some of the tools that we can use to compile, test, and deploy our code. In future videos, we'll build on some of these basic concepts to create some contracts that are a bit more complex, interesting, and useful. So stick around and let's jump right into it. All right, so before we jump into coding, I just want to take a minute to review what a smart contract actually is. So what is a smart contract? Well, the term was actually coined back in the 90s, and the basic idea is that you have code as law, okay, which means that you have code that executes and fulfills some terms of a contract, and that code really can't be altered or influenced by any outside third party or system. Just the code itself is the sole keeper of the terms of the so-called contract. So that's kind of where the contract part of the term comes into play. Now, although the term was coined back in the 90s, I don't think it really reached mass consciousness until the advent of the blockchain in recent years, especially with the Ethereum blockchain, where you can actually deploy code onto that blockchain and have it execute. Okay, so at its core, a smart contract is a program that runs on the blockchain. Now, the blockchain is a decentralized distributed computing system where state changes are allowed only after achieving consensus of a majority of participating nodes. That means that smart contracts are, for all intents and purposes, immutable. In other words, unchangeable. So to change a smart contract, to edit the code, you would actually have to make changes across the entire blockchain. All right, so this model provides an extremely high level of security. From a programming standpoint, however, it's a bit of a double-edged sword. So you have that security, but yet you have to take a little bit more care in developing smart contracts because once deployed to the blockchain, they cannot be changed. So the only thing you can really do if you discover a bug is deploy a new contract, a new instance of that contract to the blockchain. So as you can imagine, with Ethereum gas fees, this can become quite expensive. That's why testing is really more important than ever for smart contract development. All right, so one last point I want to cover about smart contracts. They can be written in a number of different languages, including Solidity, which we're focusing on today. They could also be written in other languages such as Rust, Go, Java, JavaScript, C++, etc. So we're focusing on Solidity, and the reason for that is mostly because, well, it's the most popular language for smart contracts. It was designed specifically for use in smart contracts by some of the core contributors of Ethereum. It's got a really large community, lots of resources out there, and lots of good documentation. All right, so with that, let's jump right into it. All right, so there are a number of different tools out there that we can use and different IDEs to author smart contracts. The one that we're going to be using today is the Remix editor. This is an online editor that is really useful for sort of doing rapid prototype development, testing out ideas, and just deploying and testing code quickly. Now, in future videos, when we build more of a production level smart contract, we'll be using some different tools. We'll be using Visual Code, Visual Studio as our main IDE, as well as some frameworks that we can use to help compile and deploy our code, such as Truffle, Ganache, and Hardhat. So for today, though, let's just open up a new browser window and let's just Google Remix IDE. And we should find the first result is Remix Ethereum IDE. This is what we want. So let's go ahead and open that in a browser window. And basically, if this is the first time visiting Remix, you can X out of some of these prompts here. But what's going to happen is it's going to load a default workspace with some sample contracts and scripts. So let's just expand the contracts folder. Let's double click on number 3, ballot, and let's just go ahead and select all the code here and delete it. We're going to start fresh with a blank slate. All right, so now we've got a good clean slate to work with, and the first thing you may notice is the file extension .sol. So if you haven't seen this before, that is the default file extension for Solidity files. All right, so we're not going to actually change the name since this is just going to be a kind of a quick mock-up. Let's just go ahead and get right to the coding. So I'm going to write the first line here, and then we'll stop and explain what this means. So I'm going to do pragma solidity caret 0.8.11. Okay, now you might be able to guess what this line is doing here. So 0.8.11 is the most recent version of Solidity at the time of this video. And so what this line is just declaring what version of Solidity this contract is going to be authored in. And the compiler will read that, and so it'll know what version of Solidity that it's dealing with when it goes to compile the code. So this caret just means basically that it will use any version, any minor version up to but not including 9. So if tomorrow 0.8.12 is released, it will use that version. Okay. All right, so what kind of contract are we actually going to write here? Like I said before, this is going to be a very simple contract, just sort of an input-output thing. And what it's going to do is create and return a greeting. All right, so let's define the contract with the contract keyword. We'll call it greeting. Notice I'm using a capital letter to define the contract name. And you know what? Let's just go ahead and change the file name. You know, it's good practice for the file name to match the contract name. So let's just go ahead and fix that right now. I won't be lazy. There we go. All right, so we've got our greeting contract. Now, the first thing I'm going to do is declare some so-called state variables. Okay, these are variables that will be stored on the blockchain and exist or persist between multiple invocations or calling of the smart contract code. All right, so Solidity is a strongly typed language, which means we need to first declare the type of the variable. Okay, now we're going to declare our access modifier, public, which means that this is accessible to anybody and everyone. Now, the thing about smart contracts is even if this was declared private, it would still be visible because anything on the blockchain is visible to anybody. All right. Now what we're going to do is define a greeting prefix. So we've got a name and a greeting prefix, which is going to be hello. So again, I'll declare a string public variable. We'll call it greeting prefix. And we'll just say hello with a space there. Okay. Now you can probably already tell that, you know, if you have a background in JavaScript, a lot of this code will probably look pretty familiar in terms of style and syntax and things like that. So Solidity is really, you know, not too difficult for someone to pick up who has experience with a programming language such as JavaScript, Python, or Java, or any of the C languages. It's got a lot in common. All right, so the next thing we're going to do is declare our constructor function where we'll set the name. Okay, so I'm going to do constructor. The constructor keyword defines a constructor function in Solidity. And then we'll add a name argument, which we also have to declare the type for. String, and let's do initial name, just to differentiate it from our state variable name. All right, now inside here, we'll use the common pattern of setting our state variable to the variable coming in through the argument, initial name. Okay. All right, so far so good. Now we can imagine a situation where we may be setting the name with the initial constructor call, but we may want to set the name again in the future. So let's just write a quick setter function for this. So we'll say set name. Oops. All right, let's back up a step. So to declare a function in Solidity, we use the function keyword. followed by the function name, followed by the argument list. So again, this is going to be string, and let's call it new name to differentiate it from the other two. All right, now after that, we're going to declare this as a public function, which means it can be called by any other function in the smart contract. And inside here, we'll do something similar to what we did in the constructor. We'll say name equals new name. All right. Now, let's go ahead and write a corresponding getter. So again, we'll declare a new function, and we'll call this one getGreeting. All right, this one's not going to take any parameters since it's just returning some information from the smart contract. Public view returns. Now we're declaring the return type here, and again we have to declare the type of that return type. And let's put some curly braces here for the function body. All right, so you'll notice a new keyword here, view. What view means is that this function, it's basically saying that this function is not going to change any data on the blockchain. Now there's another function type which is called pure. And pure is similar to view in that it doesn't change any data on the blockchain, but in addition to that, it also doesn't even read any data from the blockchain. Okay. So since we're reading, we're going to be reading the name and the greeting. We're going to have this as view. Okay. All right. Function body. So we're simply going to return. And so what we want to do is return a combination of, or a concatenation of the greeting prefix and the name. So we get hello Jonathan, hello David, hello Paul, whatever it is. Now, one thing to notice here is that string concatenation, unfortunately, is not straightforward in Solidity. So we can't really do something like, something like we would normally do in JavaScript, hello plus, variable name. That doesn't work in Solidity. So we have to actually use a helper function here. And this is ABI encode packed. Okay, and then we pass in the two strings that we want to concatenate. Greeting prefix, oops. I hate when that happens. Okay. And name. Okay. Now, one last thing here. We actually have to cast this whole thing to a string. Like that. So we'll put the whole thing in parentheses and cast it to a string. All right, so we're not really going to get into the details of this method here because, string concatenation isn't actually something that you would do all that often in smart contracts. Smart contracts are mostly for sending transactions and for deciding the logic behind, who gets sent which funds and things like that. But for this example, it's a simple example, so we just want to do a little string concatenation. Suffice to say that we need to use this helper method for now, and we won't worry too much more about it at this point. All right, so let's do Control S to save. And you can notice here that the IDE will give us some warning or error messages here to help us make sure we're writing good code. Parse error, source file requires different compiler version. Okay. So that means that the compiler is currently not set to this version of Solidity. So the way we can fix that, if I can remember where it is, compiler version, where is it? Right here. Okay. So we can just expand this drop down and choose the correct version, which is 0.8.11, and save it again. Okay, so we're looking good now. Oh, maybe I spoke too soon. Let's see. Oh, okay. So this is good. This is going to help us make our code just a little bit more valid and robust here. This is saying basically that our SPDX license identifier is missing. So it's good practice in Solidity to declare, your license. So what kind of license are you using? And here's the syntax for that. So we'll say spdx, all caps, license dash identifier. All right, and this is just a standard, so you would follow this same syntax. And then you would enter, what kind of license you want to use. And I just almost always use MIT. That's just an open source license, no restrictions. Anybody can use, copy, and replicate this code. So let's do Control Save, and that error goes away. Okay, let's see what else we have here. Data location must be storage or memory for constructor. Okay, so in Solidity, all of your variables, with the exception of your instance variables, can be stored in different ways. And let's see, I've got a little blog page here that can help us see what this is all about. So these are the 3 different options for variable storage in Solidity. Storage, this is the default one that our instance variables are using. Variable is a state variable stored on the blockchain. So the data from this variable is going to actually be stored on the blockchain and persisted there. All right, that's why it's important to have our state variables set to storage, which they're implicitly set right now since they're not declared. And we don't typically have to declare a storage type for instance variables. We do want to set them for anything like function arguments or, yeah, I think that's the only place we actually have to do it here. Okay, so memory, this is the one that I probably use most often in functions. And this just means that the variable is stored in temporary memory and is basically erased when that function exits. Okay. Then we have a third type called call data. We won't be dealing with this one with this particular example, but as you can see here, it says it's a special data location that contains function arguments only available for external functions. So you remember that we went over a couple of different function types. Public and private access modifiers. External is another one, which means that this function can be called from other smart contracts. All right, so for now, we just need the memory data type. So let's go back here and see where we need it. So we can add the data location type right after the actual data type. So we could do string memory here, Control Save. Good, that error is gone. We'll do the same thing here. And we need it in our return type here. We've got no function arguments, so we don't need it here. We'd need it in our return type. All right, great. So we're looking good now, and just make sure you Control Save this file. Now the next thing we're going to do is going to be to learn how to deploy and test this code and see how we can interact with it. And the Remix editor allows us to do all those things. All right, so our smart contract is now code complete. And so the next step that we need to do is compile the code. So definitely important to remember that Solidity is a compiled language, similar to C languages or Java. And unlike JavaScript, which is an interpreted language, which means it doesn't need to be compiled, it's just read directly by the browser or by the node runtime. So we can very easily compile our code in the Remix editor by clicking on this button here, compile greeting.sol. So let's do that. And let's see, did it compile? I didn't see any kind of success message. I'm just going to try it again. Okay, I think it's done. All right, so now what we want to do is move down to the next tab here, which has this Ethereum kind of icon, deploy and run transactions. So this tab is actually going to let us deploy our code, and we're not deploying it to the real blockchain in this tutorial. You've got some environment options up here. Injected Web3 provider. Make sure that you've selected JavaScript VM. Now, this means that we'll deploy our smart contract to a JavaScript-based virtual blockchain for testing purposes. Okay, so we won't have any gas fees or anything like that involved. Then let's just take a look at some of the other tabs here that you'll see. Account, this just basically when you choose the virtual machine as your execution environment, it'll set you up with a bunch of accounts, each loaded with 100 Ether. It's not really relevant in this case because we don't have any financial transactions. We'll see the gas limit. We'll talk more about that in future videos as well. Value, in case you're needing to send any sort of Ether with the transaction. And then our contract. So we've got our greeting contract selected. Now we can deploy it, but we want to set an initial name. If you remember, our constructor is taking a name argument. So I'm just going to write my name here, Jonathan, and let's go ahead and click on deploy. All right, so that was very quick. We see our success message here. Now if we scroll down a bit and go to deployed contracts, and I'm working without a mouse here, so how do I get down? Use the keys. There we go. All right. So we can see under deployed contracts, here is our newly deployed greeting smart contract. So let's expand that. And what you can see is that it's giving us, it's sort of spelling out all of the functions in our contract. All right. So if we go back and look at the code a bit, I want to mention a couple of things that I forgot. So whenever you define a state variable, you automatically get for free a getter function with the same name as the variable. So that's basically what this is right here. All right, so if I click on this, it should return the name. And there we go, Jonathan. Same with greeting prefix. Notice I don't have any function defined called name or greeting prefix. It just sort of gives you this behind the scenes for free. Now here's our get greeting function that we did define, and let's see if this works. And there we go, there's our hello Jonathan greeting string. All right, so the last thing we need to test here is if we can set a new name and then have that reflected in the get greeting. So let's do a new name. Bob. Set the name. And let's try get greeting again. And there we go, hello Bob. So let's try it one more time. Santa, since it's just Christmas and New Year's recently, or actually today is New Year's Eve. And hello Santa. So we are looking good. It appears that everything is working as intended in our contract, and we're able to play around with some variables and some values here. We're able to call the functions and do everything from this editor. So, like I mentioned before, this isn't something that you would use for a full-scale production project, but it's great just for quickly trying out ideas, quickly sketching out smart contracts. And then as we'll see in the next video that I plan on making, a lot of times I'll start development of a smart contract here in Remix. And then once I'm pretty happy that it's working, I'll sort of take it, copy, paste it into Visual Code, into a more sort of production-ready development environment. All right, guys, so that is all that I've got for today. Hope you enjoyed it. I know we just scratched the surface of Solidity, and I'm sure there's a bunch of things that I forgot to talk about, but that's okay. I've got some future videos planned where we're going to write some more sort of interesting, in-depth smart contracts. So the idea here was just to get you oriented, just sort of see what the structure of a smart contract looks like, and get familiarized with some of the tools that we can use to start authoring these things. So just a little something to get your feet wet. Hope you found it interesting, and I hope that you join me in future videos where we'll be doing some more interesting work with smart contracts. All right, guys, thanks so much. Happy New Year, and please feel free to like and subscribe if you enjoyed this video, and hope to see you in the next one. All right, guys, take care. Bye-bye.